just say each one of these is something that is not found out in other theological or just other sources. This is stuff that's original to here. What this is not right here, which is what you were asking about. So we'll get to this in 1 second. I'll note that, I believe that God sovereignly ordered the world out of what he conditionally knew would be people's free choices. And so he plays four-dimensional chess in the hardest possible chess mode. So the chess mode, the different modes that you can play chess in, different restrictions on either player. The hardest chess ever to play would be all the pieces on the board you have to ask to move, and they get to choose whether they're going to listen to you or not. And by the way, you might ask your knight to move, to Queen's Rook 3, and the knight says, not only am I not going to do that, I'm going to do something for the other team. So tell me that's not the most challenging chess you could possibly play. At the end of the day, you'd have to know the players well, so that you could ask the knight to do something, knowing that the knight's going to do what the opposition would want him to do, and then you've already countered that. That's the kind of chess God has to play if and only if he's got a dedicated end of the desire for the end of the world, and we all have free will.
So does he know what the knight's going to do because he knows the character of the knight so well, or because he sees all the possible outcomes? So do we want to get into that?
So no, I think I would love to get into that. But before we get into that, let me finish this, and we'll get into his question first, and then your question second.
I don't see the words free will in any of those 6 bullet points.
They're not. They are baked in as necessary assumption. Yeah, so that is basically a going assumption in this class, unless otherwise specified. So if someone says, let's not assume we have free will, now what? We argue like that in here all the time. But
may be the position I frequently take.
Yes, you're not the only one. So people go back and forth on that one. In fact, almost the entire atheistic world holds that free will is illusory. So we don't really have free will. Maybe not the entire atheistic world. The more vocal parts of the atheistic world say that. So of note, in all that sovereignty, I think that God, if you're listening very closely, drops little hints about what he wants you to do to lead you to what sometimes he hits you in the face with a 2x4. In my case, my family, that's like a family motto, is 2x4 required to change minds. But the subtle hints are there, and I just got contacted again this week by somebody who said, hey, we enjoyed the debate. I've never heard this before. Where can this be found? So there was one of my questions about, should we make this argument? It turns out, by the way, I was wrong about what Loftus's argument was going to be. So I brought this into it and made a large point out of it, erroneously, because he wasn't focused on this, even though it was the topic of his most recent book.
He wasn't even focused on it.
He wasn't focused on the debate at all, which did take me a little bit by surprise. But this I thought was, this must be the time for this thing to come out. And now I understand it's a person. But somebody is making the point of, like, this is interesting to me, and I haven't seen it anywhere else. So if this is good thinking, then it's maybe the time to start putting it out there. This one right here was, this is big in the non-theological world, in that a guy named Nicholas Bostrom, Oxford philosopher, came up with basically an argument that says it's almost certainly the case, based on this anthropic reasoning, that we're all in a simulation, that this isn't the real world. And although it sounds like almost a throwaway viewpoint, lots of people, Elon Musk as an example, has said, I think that's probably right. And so it got a lot more momentum behind it, and so it needed some sort of doing. Eric is the one that turned me onto it originally, and then I wrote a paper on this one, and because an opportunity popped up to go to MIT to talk at their human-machine collaboration, I was like, we'll do it here, thinking this is going to be the least successful presentation of all time. Because it's a bunch of geniuses out there doing mostly defense technology and how AI and machine learning can help in targeting, and UAS swarm technology and all that kind of stuff. And I have this poster up on the side that says, substrate independent artificial intelligence is it's infinitely improbable. And I had been assigned the corner of the back room, and so I printed out a bunch of papers and put it down, had the poster up there, and basically walked away from it being nobody's interested in this. And the organizers came up to me and were like, is your presentation this one? And I'm like, I'm literally about to get thrown out of Lincoln Labs. This is great. And they were like, I was like, yeah. They were like, people are really interested in this one. Can you come back to it and answer a bunch of questions? And by the way, this is supposed to be a no photos place, but people want to take photographs of your poster. And I was surprised because this was an engineers conference, but all the engineers were interested in the topic. So just because they're engineers, like a bunch of engineers in the class, doesn't mean that we don't think philosophically. And so I took that to be like, oh, okay, Eric's onto something. This really was of high interest. It's not just YouTube videos of, clickbait stuff. People are genuinely thinking about this. So anyway, and it's become ChatGPT gave this topic a recent boost. So people are like, are the people who write my college papers now about to take over the world? And what does that look like? All that's bound up in this a little bit. This one we presented at the EPS ETS National Conference back in 20-something, 17, 18, sometime around there. And it had some interest, but everything was in relatively small presentation blocks. I thought the most interesting statement was almost everybody that was presenting in this area were presenting Trinity arguments. It was the topic of the National Convention at the time. And the guy was listening well enough to it that it presented before me that he said, well, if your argument's right, it means that everything I said was wrong. And I was like, yeah, I don't know that it's wrong, but that would be correct. If this is right, then yours is wrong. And so he was less than excited about the prospect of this being correct. Because I think it was one of his doctoral papers that he was trying to get done. This one right here, I don't know how interesting this will be, but this was Sam Harris wrote a book on this. And if you analyze Sam Harris's book, it turns out that his major premise ends up making an argument that only somebody like God could ever actually tell you what is morally right and wrong. And so there's an argument that goes with that.
Isn't Sam Harris an atheist?
Sam Harris is an atheist. He is one of the original four horsemen of the New Atheism. New Atheism has fallen off the cliff. So there was in the New Atheist movement, Harris, Dawkins, Dennett, and who's my other one? Hitchens. So Hitchens died. Dennett is kind of odd philosopher with really weird views, enough of which people are like, I don't know if the guy's making sense. He's like, the idea of an apple could have started the universe. And we're like, okay, Daniel, thank you. But Harris and, a lot of Harris's traction seemed to me to come in the wake of his criticism, mostly of Islam, in the 2001 and later time, when it was popular for a little while to be highly critical of Islam, and then it stopped being popular for a while. And he bridged both of those gaps with some of the writing and talking that he's done. And at any rate, the New Atheist kind of fell off the charts when they had something called Elevator Gate, where a YouTuber or content creator named Skeptic was coming back from kind of one of the conventions, after party events or whatever, and she got in the elevator, and another guy was in the elevator with her and asked her, do you want to come back to my room for a cup of coffee? And she said no, and they parted ways. But she wrote subsequently about how uncomfortable that made her feel, and please don't do that. And there was a huge backlash against her, and then a backlash against the backlash that was very similar to Gamergate, for any of you that know the Gamergate stuff. For those of you my age that don't know what I'm talking about, bottom line is 2 internet tribes went to war, and the subsequent negotiated peace meant that the people who were originally part of it, some of them went down pretty hard. Richard Dawkins wrote a letter back to her, not kind of like in general saying, "Dear Muslima," and it's supposed to be written to a Muslim lady, and he's like, "Oh, you need to be quiet about all the suffering you're going through, being he details all the things that he thinks Islam do badly to women." He goes, because this lady got asked for a cup of coffee in the elevator, so he's making fun of her. And then the backlash against Dawkins was fairly large too. So the New Atheist movement started to fragment a little bit, and then the LGBTQ plus. A lot of people abandoned that one and kind of got involved in this other topic that was more popular at the time. So I don't know. I think the argument ought to be made. I don't know how much traction it has in the real world today. This right here, we're working on with a team from here. I ran into a long rabbit hole this week, so actual progress limited, but foundational progress was there. So hopefully we'll get closer to algorithms soon. This right here was a suggested one. This wasn't one of the new ones, I don't think. How knowledge is built was meant to be a reference to the structures that we hold out of which our knowledge is made. So right now, when you think of, if I ask you, what do you believe about pick almost any topic, very, very, very few people can say, I believe this because I believe this, and I believe this because I believe this, and I believe this because I believe this, and here's my justification all the way down to axiomatic or basic beliefs or whatever else. So what tends to be the case is, instead of us being able to stand on top of our knowledge and point all the way down like a rod that goes to the ground, or a stack of blocks that goes to the ground, it's like we're living in an apartment building. And in our apartment is, there's hundreds of apartments in here. It's 20, 40 stories tall, but we're only really familiar with the stuff we deal with on a daily basis. So we know about our toaster, we know about our bed, we know about this chair, we know about the carpet. But if we ask, like, well, what is your apartment sitting on? You're like, I don't know. I think somebody else's apartment. Well, what are the foundations? Like, I've never seen them. Does this building have footings? I hope so. How do the pipes get in here from the ground?
Boiler in the basement.
Is there a boiler in the basement, or how's this thing heated? Yeah, exactly. So, if you're in New York, it's probably a boiler put in there in 1915. Yeah. So you have the practical knowledge that people have today is so separated from the foundational assumptions that almost nobody recognizes that. They seem highly confident because on a daily basis they interact with the things in their apartment, but it turns out the things in their apartment may be completely wrongly based. And it's fairly easy to pull that apart. So this is the one-liner that I've talked about that you occasionally get the opportunity to break out. I've only really ever had one family friend that thought they were a relativist and did the whole, there's no absolute truth, and I did the is that absolutely true thing, and that was an example of where someone realized very quickly that their knowledge was not built well. So there's something to be said for talking about this topic, because this actually plugs into this. These two interact with each other a lot, because some of the original thinking on the universal paradox solution was helping people understand where they have contradictory beliefs. So this was also an example of someone who said, we should get someone from Solid Ground eventually on Joe Rogan, because it's such a popular podcast and it'd be interesting to talk to, and he seems to tolerate a wide diversity of views. And what I would have done on that, if we had representation there, would be to recommend an approach where we talk about each of the topics that would give you the premises of some of the arguments for God. And in a vacuum or in separate talk, people always agree with premises like, yes, so every effect has a cause, or modern science believes the universe exists, or of course it's wrong if the Nazis took over, that they took over the whole world. It would still be wrong to exterminate an entire nation of people. So that they say all those things until you arrange them into an argument for a God, and now all of a sudden they're controversial, right? So if you could get them to basically admit to each one of those in the course of the conversation, then at the end of it you could say, well, you believe in God, you basically just don't know it. And then they'll be like, oh yeah, all the Christians say this, we all believe deep down. Be like, no, you told me you believed in God this like 5 times in here. They're like, what do you mean? And then you lay out the deductive arguments, and you're like, if you rearrange all of your knowledge, if you just arrange your knowledge in the right order, you'll see that you already believe this. So that was something along those lines, I think, is what we were thinking.
They don't.
So you didn't?
But they don't.
But they don't, yeah, right. Or they don't. I think it's the case that people do believe things at a prurient level, but they say differently. And this is like, atheists hate it when you bring this up, but there's a reason that when the shelling starts coming in, some percentage of atheists start praying. And it's not because an argument hit them. It's because an overpressure wave from high explosive rolled over them, and it makes them contemplate their mortality in an acute fashion. And that acute fashion rises to the fore of what's Planting it would call a properly basic belief. So there's something to be said for that. Not all atheists pray when they get shelled, but because some of them do, it means that at least those said they didn't believe it, but in reality appeared to practically believe it, because why are they praying if they don't believe it?
Yeah, what I've seen with those two, I guess when people are working down their truth tower.
The last two?
Yeah.
Yeah.
Like they'll hit a point where they tap out and they're like, well, the experts have it from here down.
Yeah, right.
Yeah. Like, well,
in fact, that's exactly what Loftus said, right?
It's the expert consensus, and it's like between their ability to be certain about this is an actual paradox or a contradiction, and what the expert consensus is, but just like default to the expert consensus. It's like if they say that paradox happened, then I guess it happened.
So I think there are two solutions to that one. One of them is to cast doubt on that assumption. The other one is to show that you don't have to leave that one to the experts. So if you actually, like, you heard all the mumbo jumbo I was talking about with Hawking's view on how the universe begins. That's if you express it in the bizarre language of both quantum mechanics and particular types of topologies and math and analytic geometry. If you, this is back to the atomic languages thing, like you can say thing over the integral of a non-Euclidean surface and a mapping to a de Sitter space. That sounds really complex. But if what you really did was say, well, if you try to do a projection like we do off of a globe, like when you were a kid and you saw that we had a globe in your classroom, and then you had that Mercator projection that looks like a cut up, globe that you stretched out and stuck on the wall. Like that's all he's doing. He's saying I'm mapping from a flat surface to a spherical surface. So when he does that mapping, but instead of doing it two-dimensionally, he goes from 2 dimensions to 3 dimensions, and everybody's like, well, you're missing a dimension. Right. What he's missing is time. And so what he does is he injects into the spatial dimension a time dimension. And then you say, well, doesn't it change? Isn't the universe still getting bigger? Yeah, but he says that's not happening in time, that it's happening in space. You're like, but it's getting bigger. Yeah, but it's not time, but time's not flowing. How's time not flowing if it's getting bigger? And so the answer there is like, well, if you just say it's not time, but you say it's changing, and you say it's changing in space, and then everybody here would be like, that you can't do that. If it's changing, it's happening in time. The problem is nobody's challenging Stephen Hawking on that one and saying that's not philosophically, metaphysically possible. So
change is time, time is change.
Yeah, I think if that's not right, you certainly don't have one without the other. I tend to think that that's probably right. But there's a flow to time that may be a flow to change, which is why entropy and time seem to move in the same direction. So I happen to take your view, but I haven't justified it yet.
I think what he said is very accurate, and I've looked at why do people believe what they believe when rationally, they come up with stuff. And it goes back to the theory of trusted source.
Yeah.
We have, starting day one, a theory of a trusted source. You trust what your parents say when you're little. You don't stop and question it. And as you get older, you can pick and choose who your trusted sources are. And I've talked with people, and you can go through the rational arguments of all this, and then they just stop and say, well, so-and-so said this. Where are you coming from? and well, that's their trusted source. And it's interesting, when you start attacking their trusted source, it gets personal real fast.
Yeah.
And you can do all the rational explanations you want, and show this and that, their premises, but when you start attacking their trusted source, they really get defensive and take it personal.
Well, this is the second point I was going to bring up with him. Now, I will make one side note, which is, you're right, that initially, people believe their parents. Unless you're such a clever fellow, you're like, I'm going to teach my kids from a young age to question everything. And then now, guess what I have to do? Justify absolutely everything that I say, because I've taught them to question it. I'm like, fool that I am. Like, I should have waited until later before I did it. Right.
And there's some things in life you just have to take that. If somebody comes running in and you're out in your yard and somebody comes running in and says, hey, there's a fire in your basement.
Yeah.
Well, let me see now.
Hang on a second. Do I really trust you to tell me this stuff? Right. That's right.
Run down, check it out real quick.
That's right. That's a good point.
So to some degree, you have trusted sources. You can't sit and evaluate everything in your life.
So the other thing that I would like to, that I think is a reasonable answer, and the problem is it sounds like you have to give both parts of this following point. But the first half of the point is, should we trust experts? Well, let's do a historical analysis of how good the experts have done over time. And when you run that analysis, what you find is on something like anywhere from a 5-year period to a 100-year period, the experts are wrong 90-something% of the time. So if you go back 100 years and you look at a textbook and you say, what percentage of this textbook by weight is now stuff that we believe is wrong? It's probably 40% or something like that. If you go back 200 years, it's close to 90%. If you go back 300 years, it's 95%.
Notwithstanding the gospel.
Right, I'm saying textbooks. That's right, notwithstanding the gospel. But let's say the gospel's in that 5%. It still remains true. But if you turn around and you say, well, what's the current scientific debate that we're having right now? What's the one thing science can't do? what the one thing science can't do right now is tell you, is space itself quantum and quantized, or is it relativistic, like general relativity and continuous? Is it the singularity and a smooth surface? Is it quantum and probabilistic? And we still don't, and unifying those two things is the grand dream, and it was, 10 years ago, 10 years ago or so, people basically made arguments for these two will never unite, we need a new theory completely. Well, where did this idea of, are things really at base atomic, or are they divisible all the way down to zero? This is the exact same debate the Greeks were having 2,500 years ago. We have made, and sounds like a controversial topic, the way to say it, but this is the truth. We have made zero progress in terms of coming to a conclusion as to which of those two is correct. So now, of course, we know far more than the Greeks as to what happens at atomic and molecular level. But that knowledge has not advanced us one whit in answering the question of which two of these is true. So scientific progress that has occurred has been great in some of the technical fineness by which we can adjust and view things, but it has not helped us answer the question at all. All it's done is sharpen the question. So it's like, here's a problem, and now we put a telescope at the problem, we focused in on the problem, we're like, wow, it's a really big problem. And someone's like, no, you're just looking at it through a telescope. And you back it back out, you're like, same problem. So this is an interesting point. Now, it doesn't mean that you just quit on science, but what it does mean is we should stop with this modern belief that's like the next person who's a scientist of any type that steps up in front of the camera and says, well, we now know, fill in the blank, if you're not laughing, you're not paying attention. And so we should be very conservative about what we accept and certify as true. In short, if it hadn't made it 200 years, then it needs to be in the questionable bin. And if it has made it 200 years, it needs to be at least sitting on the plate that says, is there some completely new view of the world writ large that makes this not entirely accurate? So I don't really know what you would call that topic, but I think that I believe that it is eminently worthy of discussion. I'm not 100% sure, again, how to do that in 5-minute format, but maybe something else that we put on there. Think about it for a bit, give me a name for that, and we'll put it up there.
I don't have a name, but we kind of touched on it last week, and I'm going to let you know how we touched on it. When we talked about things that were contradictory where both were true. Okay, I'm going to give you a very simple example.
I don't think anything falls in that category.
I'm going to give you a very simple example, okay? Particles are both waves. They're waves and particles, which that's a conflict. They can't be but it's true.
It's not true.
Every particle can be represented as a wave. Every particle can be represented as an object.
Yeah, but it doesn't mean that actually it's both. And the problem is when you model it as a wave, some of the times you're wrong. And when you model it as a particle, some of the times you're wrong. So that doesn't mean that that's true. What it means, my point is this: if someone makes a statement to you like that, you know for a fact that they're wrong. That's the important part. Anytime somebody tells you something that contains a contradiction, you can say without question, you're like, I don't know what the truth is, but I can tell you that that's not it.
Okay, well then let me get away with it this morning, since it's only an example. It's not really the point that I'm making.
Fair enough. I'll suspend literally all of my knowledge down to the basic level for you. That's how much I love you.
Thank you, because I only have an 8th grade education, so.
It doesn't seem like it. You can't claim to have an 8th grade education if you continue to learn after 8th grade.
Okay.
You've continued to learn after 8th grade, therefore you don't have an 8th grade education.
Now we're getting lost here. Okay. The notion of whether the universe is quantized or continuous.
Yes.
Okay. Those seem to conflict.
Yes.
Okay. But my personal viewpoint of the answer to that, which is not a specific answer, but my viewpoint of the answer is that our God is so incredibly amazing that he could develop in his physics, a universe that is both quantized and continuous. So do you understand what I'm saying?
I do, but let me bifurcate that in 2 possible paths, and then you can select which path you want to talk about.
Okay.
One of them is, it could be the case. So you have to specify far better than I have what exactly you mean.
Yeah,
so
I didn't do too well either.
I'll do a better job of it. Space itself. Does space itself exist? That's point 1. And if it does exist, is it divided into discrete small units such that, like, here's this
That would
point.
be
Here, if you
quantized.
zoomed all the way in, yeah, and so I'm being specific about it. If you zoomed all the way in, here's a unit of space, and next to it is another unit of space. And if you're going to move from one to the other, you're at this unit of space, and then all of a sudden, you're at this unit of space. There's no movement that happens between it other than snap off and snap on.
Mhm.
So that would be quantized, something like quantized space. Continuous is like, yeah, space is divisible amount here, but if you move from one of them, your little thing actually moves from this one to the other. That's continuous. It looks like it's quantized, but in fact it's continuous. That is to
You
say,
can be in the middle.
you can be in the middle.
You can be in any middle.
You can be in any part that you choose. So those two ideas are not compatible. It can't be both. It has to be one or the other. That's all I'm saying.
Not in our brains.
Not even in God's brain. And here's why. I'll ask this question. Can God make a married bachelor?
I don't know.
Well, we think we do know in here, and the reason that we say God cannot do that is we don't think that it's the case that God can do anything. We think it's the case that God can do anything that's logically possible. Now, when you turn around and you say, tell me about the concept of this married bachelor that God's not powerful enough to create, and so you try to describe a married bachelor, it becomes very clear that you're actually lying.
Yeah.
Because there could not even possibly be such a thing as a married bachelor, and God's like, I can't make up your lie. Like that's not something an all good God could even possibly do. So that's not even a thing. Would be, I don't know that God would say it that way. There's no verse in the Bible that says that's not even a thing. I don't do that. So that's what we're talking about. We're talking about that.
Just one question, because we're on this topic.
Sure.
Do actual infinities exist, or just potential infinities?
Potential infinities.
So there's no material that comprises an actual infinity.
So this is what, like, I had this discussion with a guy who quit on it way too early, and I was bothered by that. But the reason that we want to do this is when you say, so this is an infinite.
It was probably to his credit that he quit early.
Well, maybe. Infinite space. Yeah, maybe it meant he's wise. That means, literally, when you take it out of Latin, you say not ending. And ending is a verb, and a verb is an action, and it's a particular kind of verb that says there's a process going on. And the process is we're counting or we're measuring. So I'm counting, I'm measuring, and so if you ask the question of like, how do I get to the end of a non-ending process? You'd say your question contains a contradiction. Pick which one you mean. How do I get to the end of a process that ends? Or if a process never ends, then by definition it's not ending. So whenever somebody says there's no end to infinity, infinite space, you're like, that's contained in the definition. You're not making a particular claim. Or if someone says, how many times can I divide space? And if the point is division is a process, then what you're saying is, as long as I continue to divide, when does it end? And the answer is, hey, smart guy, it's whenever you stop dividing. That's when it ends. So the question was basically between this point here, that's not a very good point, and this point here, the person was saying there are an infinite number of divisions in between these 2 points in space. And I said, who divided them? And he was like, what do you mean? And I'm like, well, you say there's an infinite number of divisions, but a division is an act. It's not a space. If you're saying there's an infinite number of spaces in here, then I'm going to say, what if I just claim that's one space? Like, it seems to me to be one space. Why are you saying it's 1,000 spaces or 1,000,000,000 spaces or an infinite number of spaces? In order for that to happen, somebody has to have divided that space up into smaller spaces. Or it's the case that it was a bunch of smaller spaces and they aggregated it into one big space. But it depends on how it was built. If it was built as a unit, then divisions are arbitrary and they're mental or physical. Like if you can cut space with some space cutting knife, you could do that too. If, however, it was built constructively, where either the laws of physics, as Hawking would have it, or as God added together a bunch of dots to build out this grand universe, then there is some number of divisions that he put together, and that would be finite. Otherwise, it would still be growing in size, and it would still be finite, but it may be non-ending, and therefore potentially infinite. So the bottom line is that these divisions that people keep wanting to do, they're mental. They only happen in real life. If I went to him, I said, show me where the midpoint is. And we go look at the putative midpoint, and I'm like, where's the division there? And he says, well, it's right here. I'm like, well, you just divided it.
Well, it's the Dedekind Schmidt.
Like there's no, if you could somehow look at that point and you look at the point next to it, whatever a point is, I happen to think a point is a logically impossible object, that you would say there's no difference between these two. I only called this one the midpoint because in my mind, I recognize a truth, is that the amount of distance that I have to travel to get to that point is identical to the amount of distance I have to travel to get to that point in opposite directions. And so I'm calling this the midpoint. But there's nothing other than in my mind that makes that point unique in any way to anybody else unless they also hold that idea in their mind.
So I'm following all this. Isn't there a bunch of math, though, and mathematicians that talk about, they use infinities and they talk about orders of infinities?
Yeah, and it creates incredible contradictions and problems and nonsense. It wrecked Hilbert's project of linking mathematics to, in my opinion, linking mathematics to kind of real world logic. Some mistakes, I think, on Russell and Whitehead and Frege's side that were right in rejecting naive set theory. All are based in this kind of problematic reasoning, but they're good answers to it. Like you can have a set theory, you just need to recognize that the set itself is a thing, that you can't have elements. There are elements that are not sets, and all sets are not mere elements. And if you understand that axiomatically, then the rest of it is simple. And they tried to back into it, I think, a harder way than necessary in order to do so. But the Cantorian reasoning is ridiculous, and so I guess they're, in my opinion, and so what I would love to add to it is not this 7, but maybe 8, is I'll say it the way that I know how to say it, and we'll figure out a better way to say it to the general public. But basically that all infinites and basically there's kind of an olive sign. All infinites, we'll just say all infinites, all types of infinities map bijectively to the ordinals. And if you can... I'm
sorry, that's a new word.
Yeah,
what is bijective?
Bijection means that for every... if you walk into an airplane, 747, and there are 250 seats on it, and you look in every one of the seats, and every seat is filled, that you know there are 250 people on it. And to say there's nobody who's not in a seat. So you have a set of seats, and you have a set of people, and they map 1-to-1 on each other. So it's not one person in 2 seats, it's not 2 seats and 1 person, it's 1-to-1. So 1-to-1 with no exceptions mapping is a bijection, which is just fancy for 1-to-1. So
which can also be by the infinite sets.
Exactly. In fact, the way that they determine whether the sets, Cantor and others determine whether sets are of the same size is does a bijection exist between them. So what they'll do is say, I have the natural numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have the evens, 2, 4, 6, 8, 10, 12. I can map a bijection, 1 to 2, 2 to 4, 3 to 6, 4 to 8. And I can 1-to-1 map because I can do it infinitely. Those extend infinitely. And so there's a bijection between those two so they're the same size. Same size of the evens to all, the evens and the odds together, which very obviously is silly, right? We know that's not true.
No, it's not silly
at
all.
Well, it is silly because let's say I've got the odds and I've got the evens. Are those the same size sets?
Yes.
Okay. Now I've got both of them together. Are all 3 of those the same size? Or do you add these 2 sets together to get this set?
They're all the same.
Well, I happen to think that that's silly. I apologize for pejorative language at this point. But I think it's obvious that each of these sets are half the size of this set. And the difference, what the difference is, in order to make them all the same size, you have to count.
I've seen them as equal for too many years to undo my thinking.
But you've been brainwashed to do so. So what I would do, then turn around and do is say, I can map each of those to the ordinals. And so we can say all infinities are the same size. And even the ones that divide, where you say like, okay, well, I'm going to go between 1 and 0. And I'm going to divide half. I'm going to divide half again. I'm going to divide by thirds. I'm going to divide all of these. And there's never a first number between 0 and 1. And there's never a last number between 0 and 1 because you can always find some space in between it. How do you map that to the ordinals? Well, you map that to the ordinals. Right. Right. So let's say Dedekind cuts, and let's say there are a finite number of methods that would give you all of the numbers in there. If there are a finite number of methods that give you all the numbers in there, then you simply assign an order to which one of those methods you use, and you map those to the ordinals, and now you can one-to-one map you can map the output of those to each one of the ordinals, and so it's the same size as the set of the ordinals, so that makes all sets the same size. That's basically the argument. But, so we don't, re-engage if you want. If there's a better way to say this, like without boring everybody who's not into number theory, this would be interesting to point out, because a lot of the problems that we have in quantum mechanics and let's say cosmology have to do with renormalization, and even the solutions to answers that we think that we've got, like the one solved millennium problem, they depend on when a singularity appears in the math, that you cut the singularity out and you pretend it wasn't there and you reconnect it. So the guy who solved the only millennium problem did it with a technique called Ricci flow with surgery, which sounds weird for a mathematician to be saying that, but what he means by with surgery is when he flows these multi-dimensional surfaces in, when they tie together and make a singularity, he stops the process, reaches in, mathematically cuts it, pulls that out, and reconnects the two surfaces together, the two circles together that went down this necktie. He cuts those out and sticks them together. We would call that cheating if it was anything else, right? Which you're like, but that's not what mathematically happened. He's like, yeah, but if you let the singularity stay there, you'll never get to the solution. And you're like, right, but the singularity is there. Right. So, but then to me, if you cheat, it's not the right answer. Mm-hmm. Right. That's an axiom I have. If you cheat, it can't be the right answer. You need a different mathematics.
It's not really cheating. It's technique, but it's not cheating.
Well, what you're saying is
we use the word cheat, but cheat is not really.
If the technique requires you to say the solution to this problem can be found by the following process, except when the process doesn't work, then you follow another process. But you only do that process if this process doesn't work. If we logically turned around and said, I can use a cutting process anywhere, then I can tell you that an infinite long string of things is 3 objects long, is 3 numbers long, because I'm just going to make a cut between 1 and 2, I'm going to make a cut between 2 and 3, and I'm going to make a cut between 3 and infinite. I'm going to throw all that away, and I'm like, look, infinity is 3 numbers long. So you're like, no, you can't use the cutting process that way. You can only use it when I need to use it. That's the taxi cab fallacy of like, I'm going to dismiss the process if I don't like, I'm going to use it up until I need it, and then I'm going to dismiss it after that. So no, math can't cheat. It has to be continuously applied the whole time, or it's not the right math. That's the point. But we've given up on that because none of the math we have works in all regimes. And so it was either cheat or throw the whole thing out and start over again. I think we should have thrown the whole thing out and start over again because we'd be closer to the real answer. But I'm not an instructor of mathematics, nor am I Greek, nor am I ancient, nor do I look good in a toga. Touche, sir, touche. Well played. And check.
Can I get one last word in on this?
You may have 5 last words on this.
Very short.
This is solid ground. There is no last word. It is an infinite process.
When we're talking about infinities, okay, there are infinities in mathematics. I'm not saying there are or not, but there's the question, are there infinities in physical reality? In one last area, is God infinite?
Well, this is why I like to use
these are
the
very
terms.
different kinds of infinities.
So let's address each one of them. Mathematics, reality, and God. Now let's separate God from reality. Not that he's not
I don't know if reality is the right term, but
reality is fine for physical reality or whatever you want to use.
Okay.
So if you ask the question now in Michael's atomic language, which is now, this is not going to be Michael's atomic language from here on out. He came up with the term, so now it's his term. Whoever coins it gets it. If you have, let's state it in what we really mean. Let's stop using Latin and ask the question in English. Okay, so now in mathematics, does mathematics contain non-ending processes? So the question then should be, who's doing the math?
How deep can you go in Mandelbrot?
But
you don't have to go very far.
But no, that's exactly the right question to ask. So here's the question. Wow, who thought they were showing up for a number theory lecture today? I have apologized to everybody. Here's what he asked. How deep can you go in Mandelbrot? Does everybody know what Mandelbrot is, what he's talking about? So Mandelbrot are the cool fractal sets that you see of like this weird, I'm trying to draw with my hand. I can't draw fractals.
It's really easy to just move on.
It's beautiful.
Yeah. It's really cool stuff. If I need to figure out how to project YouTube videos up here. Can I do that already? I can probably do that. Why can I not do that?
You'll have this all hypnotized.
Wouldn't like an integral would be like an infinite process?
Interesting, okay.
I don't know why this got anything to do with atheists, but
Include
say there is no secular or atheistic explanation for what
I
it
don't
is.
want that one. There we go.
There you go. That's what you want.
Okay, so it's these kinds of mathematical structures, and you see how like this looks like that thing, or I guess the one we're zooming in on here. And when you zoom in, what ends up happening, I guess we're zooming over here.
This
When you
has
zoom
a
in-
finite volume, by the way.
Yeah, so it'll be a finite size volume, but there are an infinite number of divisions in here. And so you'll see that there's almost a pattern. As you continue to zoom in, it looks like, hey, wait, I've kind of seen that before. And the interesting part is there's a mathematical process that defines this, so that when you do that and you zoom in, you find that it's all kind of here, so to speak.
It's insanely easy. It's so incredibly easy.
Yeah, it looks like a very complex structure, and some people point out, like, we kind of see this in nature sometimes. Like if you look at a mountain, but you kind of zoom in and you look at a particular rock, you're like, yeah, they kind of look the same at a certain zoom level. That's the idea.
Seahorses.
So seahorses, yeah. If you zoom in on seahorses, it turns out they're made up of tiny little seahorses. That's not true. So this is when you guys are done being hypnotized. I'll make
I know, I
this
was
one. Like,
thinking, what effect does this have on us?
if you like lava lamps, you love this.
Tell them real quick, what we're doing is we're zooming in closer, like with camera.
Yeah.
You know, but, if we were doing this in real life, if I were zooming into this table, I would eventually get to atoms, and then I would eventually get to the Planck length, and there's no more zooming. But this is a mathematical structure, and there's literally no limit.
We don't have the capability of anything more zoom. We don't know what there is down there.
Well, mathematically, we would say that there is. But the point is, in order to either zoom or to mathematically calculate it, you have to do a process. That's the process of division and multiplication. And technically, division and multiplication are just versions of subtraction and addition. And subtraction is just inverse of addition. And addition is merely the result of putting together a number of successor functions. So 2 is a successor to 1, 3 is a successor to 2. When you add, you're basically saying, let me take the successor to 1, add to it this successor to 2, and I get the successor to 4 in virtue of doing so. So math all basically boils down to successor function, and successor function is a process of succession. So the reason mathematics is finite is all of it is process-based. And unless you have an infinite amount of, so the answer to how deep does a Mandelbrot set go is, I have 2 questions for you. Who's the one doing the calculation? And how long are they going to live? And then, well, I guess 3 questions. What computer are they using? What rate are they doing that at? So you get the total amount of time that they're going to do it. They're going to do it for 80 years, and the rate at which they're going to do it is they're going to make 17 calculations per microsecond or millisecond. And so when you add all that together, you're like, that's how deep the Mandelbrot set got. And it's a process. So if you ask it in English, you realize that you're asking the
So
question.
if you put prohibitions on
No, not prohibitions.
Process.
You put prohibitions on it by asking the question.
I'm sorry, limits.
Yes.
It's a better word than prohibitions, but if you put limits on the process, then, but why do you have to put limits on the process?
I'm not putting limits on the process. Time is putting limits on the process.
Is it?
Well,
Okay.
tell me how you want to generate an infinite Mandelbrot set. You tell me how you're going to do it. Like, I'm not going to give you any limits.
I'm going to ask God to do it for me.
Okay, so now God's going to, all right, God's going to do it. Fair enough. So we'll say God's going to do it. But what we're asking God is to say, I want you to do something as fast as is possible and for as long as is possible. Is that what we're saying? How deep can the Mandelbrot set go? How fast can you do this, and how long can you do this? And if the
We don't
answer
need to
is,
worry
God
about
says,
speed.
I can do it as fast as you can conceive, and I can do it for as long as you can conceive, as anybody can conceive. So now we're at something like, you've got a godlike power, you've got a godlike rate, and you've got a godlike amount of time. So the distance should subsequently also be godlike. If distance equals rate times time, then you've got a godlike rate, a godlike time, and you have a godlike distance. So what is the rate? Is it when you ask the question of, is there an infinite rate? Let's put that back in English.
You only need one of those variables. You only need the time variable.
That's-
You don't need the rate variable at all.
The rate
You
time.
can do it with a 4004 processor.
How are you going to do that? Go ahead.
You just need a lot of memory.
Right, right.
You just need an enormous amount of memory.
But every enormous amount is finite. So
But is it finite for God?
let's ask it in
Is
English.
God's memory? You know, if we treat God as a computer, is His memory finite?
Let's ask the question. Let's ask the question in English, which you did,
Okay.
but you almost did. You ended it in Latin.
Okay.
You used the word finite, and finite is Latin. So let's turn that into English. It means ending. Or does it? And so if you say, well, what do you mean ending? Or
Is
limited?
there an ending to His knowledge?
Okay, so now what does God know? When God knows stuff, what does He know stuff about?
I'm not ready to answer that, but I'd be glad to let you.
I'll make a
answer
stab
that.
at it. Yeah, I'll make a stab at it. He knows stuff about everything that does actually exist or will exist. Okay, so he doesn't. Does he know
Some
stuff
people think
about?
He knows all the hypotheticals too.
Let's say that there are hypotheticals about things that actually exist. So let's imagine a relatively small world, a world just the size of our Earth. That's huge in some quantum sense, but it's small in terms of a universal sense. So just stuff about our world. Or let's make it easier, just stuff about this classroom and the number of people in it. This is all the people in the world, and this is all the volume of space and time, and this is all the time that exists. And so he knows everything that we could do. He knows everything that we could do in 100 years, 1,000 years, 10,000 years. And even though it could keep on going and going and going, at every point that's a finite amount of things. So the question is...
Into the past, yes.
Yes. So now let's say, okay, well, but that's a limit. What about if we could be all tigers? Or what if we could all be aliens? Or what if we could be aliens that could double the volume of the room every 2 seconds? Okay, so now there are more possibilities out there. And then you say, okay, well, what if we could be aliens who make tigers, and the tigers can also do these things? And so we start multiplying things, and they multiply very fast. You can see that the size of our universe can get big quickly. But the point is, even no matter what size you start at, that process still yields you something finite. So the question is this: given a finite starting point, this classroom, are there an actual infinite number of possibilities, or do you actually run out of stuff that you can do logically? That's the baseline question. I happen to think that you run out of stuff that you
By
can
quantum
do.
mechanics, quantum mechanical view, you would not.
Quantum mechanical view bakes into it an infinite, a non-ending process. So let's not assume non-ending at the beginning. Let's
I'm not saying I espouse a quantum mechanical view, but that one would say that the answer is infinite.
That's only true if you make an infinite number of divisions of a finite space, and if in quantum mechanics, if space isn't quantized. So space isn't quantized, and quantum mechanics is incomplete. If space is quantized, if space is quantized, no, we know that. If space is not quantized, then quantum mechanics is incomplete. If space is quantized, then any finite volume gives you a finite number of quantum mechanical states. Right? So you have, in order for quantum mechanical answers to be infinite, you have to have an infinite space, which we don't. So unless God can do something that's logically impossible, is that he can make a non-ending space that ends, which he cannot do because it's not logically possible, then any creation has a finite number of possibilities into it. Now, it may be that he never runs out of types of creation that he can make. But the question is, does he do that? So maybe he has infinite knowledge. That is to say, of all the possible space. I think there's a limit to possibility. I think that there is a limit. I don't think there's a limit to how many times. But even when you do the process of ultimate division, there's always a limit to how much you can do that. It's how much time do you have to do it in. In God's case, it's how much time does he will to be. So because God's not sitting there in eternity tapping his foot eternally, if there was a beginning to time, and we all seem to believe that there was a beginning to time, then there's a finite number of things that could happen in that period of time, or did happen in that period of time, or will happen in that period of time. Which is why I happen to think that the universe reality looks like this, eventually. Oh, that's not helpful, is it?
Yeah, you spun them all around, but they still don't mean much.
The universe looks kind of like that.
The universe looks
It's a
like
pretty
this.
universe.
That God starts it. Here's God before the universe necessarily. He kicks the universe off, and here's all the people and possibilities and all that kind of stuff. And that eventually he moves all the number of changes back down to zero, and sitting at the end of it is God and all of us together, however many of us there are, all of us together existing in the same kind of state that he existed in here, as to say, unchanging. So I actually think that there's a finite volume to the possibility space of the universe, reality, in which case God's knowledge also would be actually finite, potentially infinite. Because I think that he chooses to make a world, and a world that has a beginning in time. And if he does so, then it can't possibly be infinite. But let's say that we've wandered way too far from most people's interest in the class, and that we basically ask the question, is a better way to ask this is there a non-boring way to do this? Because mathematically there's a reason to do this, and I will work on that myself off to the side anyway. But is that a topic for the world? I think it should be. I just don't know how to make it interesting.
I think the topic is, like YouTube title, actual infinities don't exist.
Right.
Because
Or
everyone's used to hearing about it in math class, and it comes as a shock when someone says no.
Or a clickbaity type title, all the math you learned was wrong. And you basically point out that all of your math prior to, I won't say it this way, but all the math that you learned prior to Gauss was geometrically based. And all of it was based in Euclid, and Euclid was based in the idea of a point. But Euclid didn't say it wrong. We interpret Euclid wrong. A point is that which cannot be divided. But it turns out there's nothing that can't be divided, at least mentally. So if mathematics is a mental thing, then there are no points. But Euclid was a constructivist. This is a point. You add a bunch of points together in a particular way, you get a line. You add a bunch of lines together, you get a plane. You add a bunch of planes together, you get a three spaces. So if you're a constructivist, everything you learned was wrong because there are no points. And if you're after Gauss, it was analytic, a kind of algebraic approach, fundamental theorem of algebra. But the fundamental theorem of algebra incorporates what? Imaginary numbers. So, like everything you've been taught, from geometry to algebra. It's not a misnomer because there is no actual square root of -1, nor can there possibly be. There's no number even conceivable, the square of which gives you the -1. So there is no square root of 1.
You and I have different perspectives.
You can change my mind in a second by telling me what the square root of -1 is.
It's what we labeled it. We labeled it I.
Well, I could have called it. I could have called it purple zebra.
You just said what it is.
I could have called it married bachelor.
You can call it anything you want. It is the square root of -1.
No, there is no square root of -1. That's what I said is there is no square root of -1. That the square root of -1 does not exist.
You can't conceive of it.
Which is true. The square root of -1 does not exist. So if what I'm going to do is say here's the complex plane, and the difference is all of these numbers are where I've added some number times the square root of 1. And I'm like, but the square root of 1 does not exist. And something that does not exist is identical to nothing, and nothing is identical to 0. So you don't get a plane by adding multiples of 0 to it. So that literally the complex plane does not exist, which is true. There are no roots to certain equations, but we extend them in the complex plane. We're like, well, if we extended them in the complex plane, then it would intersect the x-axis, but it doesn't. So there's value to it in that you can do calculations.
Beautiful Mandelbrot set exists in the complex plane.
It's also illusory. In that it
Everything
doesn't.
in mathematics is illusory.
In which case it's not true, and if it's not true, let's go back to a mathematics that is true, so we get real results, and we don't end up with renormalization problems, and we don't end up with singularities that cause us difficulties, and we don't end up with problems with our black hole theory, and we don't end up with problems when we go back to the beginning of the universe. All of mathematics would be materially improved if we didn't have to deal with infinites that actually pop up in our calculations that make all of our calculations wrong, and we have to stop doing those calculations and take all of our Yang-Mills stuff and be like, if I can't renormalize, none of this works. It would be better if we had a better mathematics.
I think 9 we could, we spent months on choices, when choices are made, and when it's possible to make choices for other people.
That's free will, basically, right?
Yeah,
Yeah,
now,
but-
now his topic gets added on here. Number
Right,
9.
and it was like, given free will, like, when is the choice made? Because we did spend lots on that. And for 7, I was thinking something like, when something is empirically identical, then like popularity decides.
Number 7. Wait, what was number 7? I'm looking at a blank here.
There's like when it's not decided empirically, it's decided by popularity.
Okay, yeah.
Or if there's a way to rephrase that.
It says and belief. Okay. Yeah. Okay. Yeah, this topic right here could have a whole bunch of different ways we could
Well, it's
go.
also like people don't think about experts operating based on popularity, but the experts actually, they care about being popular, and like when theories gain popularity, then they spread like a meme based on popularity, not based on like accuracy.
Yeah, and I think I'll tell you one thing I'm excited about is I'm wondering if the following thing's going to happen, and it does. I don't know that it helps us. It doesn't help us with finding out what's true, but it helps us with mapping the space of possible truth more quickly. Recently, meaning in the last couple hundred years, the arbiters of truth have been the academy, and the method by arbitration has been publication. It is now becoming known and maybe widely enough recognized that because of particular problems in a lot of the scientific thinking, specifically the statistical methods that are used, or let's say misused, this is why Veritasium has a video up that says why 96% of published research is wrong, right? And it's not because the research wasn't done rigorously. It's because the statistical techniques that they used in order to come up with an answer that's fairly marginal found a p-value, again an arbitrary value made up out of a textbook, that the p-value, that people have gotten to their results by misusing statistical methods, so that 96% of research, if you tried to repeat it, would not be repeatable and give you the same answer. So when you find out that your knowledge source is, let's say 96 is an inflated number, let's say it's 50%, that 50% of your expert knowledge is wrong because your experts who are doing your biological research and your nuclear research are not also experts in statistical methods, then all of a sudden it turns around that your statisticians become the high priest's knowledge. So the statisticians will relatively quickly turn you around and be like, I can't apply my statistics to any knowledge set unless you tell me something about the knowledge set. I don't know your biology stuff and I don't know your nuclear stuff. So you end up with this gap between the statistical methodology and the empirical research you're doing. And someone now has to be an expert in both. And we don't divide up our expertise that way. So at least at present. So what it basically means is, up till now at least, you should assume that if an expert says it, it's probably wrong. That's not good. Now, it doesn't mean that if a non-expert says it, that it's probably right. What it means is, just because an expert says it doesn't mean you get to assume it's right. So what I would have said if we were having a debate that Loftus was trying to have was like, let me show you why your scientific knowledge suggests that your conclusion would be wrong, and you need to dig more deeply on each one of it, and you can't leave it to the experts.
That's why we have the Bible.
Well, that's why we have a mind. And the idea is if you want to know it, then you look into it. Stop taking other people's words for it. We've got 50, 60, 70, 80 years on this earth. Do you really care about truth as much as we passionately say we care about truth? Go learn some of the basics of discovering truth. Find out what the word epistemology is. Figure out what your epistemology is. Then you work your way through there. So we are all guilty of claiming that we are lovers of truth and not putting enough effort towards it to be able to do the very basics on it. Not all. This class is better at it than 99.9% of the world is, because you guys are here and you care about it. But my point is, expert knowledge is not automatically equal. Correct.
Now you're getting into the so what factor is what I call it. I mean, what's important and what isn't important.
Well, if truth is important, then the one thing we know is important, and maybe this ports into this topic,
Truth
which
about what?
I think he brought this up years ago, which is how do we know what is true? And this is obviously just very basic epistemology. or the topic is simply epistemology. But what do we have an actual, real deal truth-telling method? And we passionately dove into this one a year or two ago, where what we said was, yes, and it boils down to this: figuring out what your concept is, and finding out if it contains a contradiction with some other concept that you have. And when you've done that, you'll at least have eliminated many lies. But that all truths have to be composed of non-conflicting concepts. And now the way that you aggregate concepts together, you realize how tough a task that is. So we should at least come out of that with some humility that says something like this: man, at the end of 80 years, we're barely going to know anything. That's fine, as long as the stuff you know is rock solid true.
But you still need to know what's important to know.
Well, that after you know what is it, one of the things you know is important.
There's a lot of truths in the world, but 99% of it, I don't care.
I agree, but what we can agree on is, hey, I want to go find truth out there. Well, which truths do we want to know? Hang on a second. Before we decide which truths we want to know, let's figure out if we got a way to know what's true at all. If the answer is, I found a litmus paper that when I touch it to these truths.
But then let's take it one step
Yeah,
forward.
but that's where I'm going. Give me a second. I'm going to take my truth-telling litmus paper that I've now got, and now my question is, all right, what am I going to go stick this on? Because my clock's ticking. I've only got 40 years.
You've got a truth meter.
What am I going to touch with my truth meter? So let me order it in terms of, like, do I have a good concept of what the truths are that are out there? And then let me rank them in importance. And then I'll go work my way down the list. That's the way to do it. Now, one of the problems would be is this, like, well, I want to know what's true out there. Well, how do you know what's out there? Unless you figure out the truth of what could possibly be out there. Turns out possible truths is a navel-gazing exercise. So I actually think we can do all this out of our armchair.
It's interesting, the relationship between what is important to know and what you assume to be a trusted source.
Yes. Yeah.
Could you
It's
zoom
not good, I'll tell you that.
Could you zoom out just a bit so I can take a picture of what we're...
You can also screen capture this and send it to you. Or maybe you can't. Time, yeah, work.
Can you ask the so what question then to all of these 9 things?
I could, but so what?
So what?
All right.
Cares?
Who cares?
I think
Who needs God?
I think a little bit in answer to this. I don't know if it's going to be satisfactory at all, but I think that God, in creating us and in creating us in His image and giving us a mind that works like His mind, I think we have inside of us certain questions, just like that we have inside of us God's moral law.
Yeah.
He tells us that.
Yeah.
Just like we have inside of us a knowledge that God exists and somewhat what He's like. He tells us that in Romans 1.
Yes.
We also have questions like, are we eternal beings or do we vanish when we die?
Yeah.
That's a really important question. How do I know it's important? I don't know how I know.
Right.
But the question is there. And I feel like it's a really important question to know if I'm an eternal being.
Yeah,
or
so
if I'm just a temporal being.
We're basically out of time, so I'll end with this one. What you're pointing at is our outstanding observations that form much of the basis of the questions that Alvin Plantinga wanted to ask and came up with an epistemology that's called properly basic beliefs, which is properly basic beliefs. These are beliefs that you're rational to hold that are basically axioms. Like you don't know where they come from, but you just believe them, and you're actually rational to believe them until someone shows you a defeater for it. So it may be properly basic to be like, it seems to me that the earth is flat. And then someone comes around and is like, well, here's a picture of the earth from farther away. Or alternately, let's go stand on this tower and go look in that direction. Do you see anything? No? Okay, come walk with me. Hey, look, here's another tower. How come we couldn't see it? Well, it's because the earth is curved. So let's say that there's a whole bunch of reasons that they give you as a defeater for your belief that the earth is flat. Now you're no longer rational, but perhaps, to hold that flat earth approach. So that kind of idea. And so he talks about properly basic beliefs and defeaters, and then defeaters, and defeaters, and so on. But that's his epistemology. So that is, I think, a good epistemology. And it dovetails nicely with the point that you make, which is like, we seem to show up with beliefs, some of them already kind of baked in. These guys believe much of the stuff that I told them are questions, but they also seem to have come programmed with some basic stuff that I didn't teach them that they already know. So anyway, okay. as Zoolander says, I'd like to continue talking about this conversation. We'll keep on this topic a little bit. We are now in a little bit of the specifics of the discussion, or starting the specifics of the discussion of the, where was it? Michael, where are we? Number 5? Yes. Well, it is part of number 5. Well, anyway, atomic language development of like, basically there are a finite number of concepts that human beings have, and we use a finite number of words to describe those concepts. And so we want to map those subjectively, objectively, or injectively together in such a way that we can make sure that we're talking about the same things. In short, a less fancy way of saying it is, let's stop talking in Latin and all start talking in English. The problem is you look at English and you're like, English is nothing but Latin and French and German all stuck together. And we're like, good point. So let's come up with some lingua franca that can be like almost numbered to say, okay, well, the French, the English, and the Americans all agree that je ne sais quoi means I don't know what. And the French may mean something special by that. We may mean something by that, but ultimately it all maps. So that's part of it. All right, well, we'll see you guys next time. And if you've got any thought, if you're interested in working on this, get in touch with either myself or Michael, and we will start working on this together. But this is now starting to come together. We're starting to put pen to paper on it. I actually happen to think it's the basis for answering a lot of these other questions too, which is why we're trying to do it.